In Chapter 7, Section 2, you're going to learn about properties of exponential functions. Now, when we talk about properties, I'm going to teach you how to stretch, compress, move left and right, and up and down the graph of an exponential function. Let's take a look at the example that the book provided for us. We have two graphs here. We have y equals 2 to the x power and y equals 3 times 2 to the x power. It should be no doubt to you that this one would be vertically stretched by a factor of 3. So if you look at over here, okay, you see this real tall one, the one that goes up a lot faster, that's the one that's stretched by a factor of 3, this one. This one here, the y equals 2 to the x, that's the original. So this one's the original, this is the one that's been vertically stretched. Now, how do the y values change? Take a look at the original y values. The original y values, here they are, this is the original. Look at every single y value in the next column. Everything's just been multiplied by 3. Let's go down and try some of these ourselves. As we come to problem 1, we see that our equation is y equals negative 1/3 times 3 to the x power. And we want to compare it to the graph of the parent function. So something important for you to realize is what the parent function would be. The parent function would be y equals just the 3 to the x part. It would not include the negative 1/3. So compared to the parent function, you should be able to know that this one is vertically compressed because of the 1/3. So I'm going to write 1/3 vertical compression, and the negative sign would rotate it around the x-axis. So kind of like it rotates it, it reflects it. So we should see a graph that is vertically compressed, and we should see a graph that is kind of upside down from what we're looking at. So there's nothing being added or subtracted to these x's up here, it's just to the x power. When that happens, please pick -2, -1, 0, 1, and 2 to plug in. So our equation is y equals negative 1/3 times 3 to the x power, and we're going to plug our x's in for the x. So for -2, we do negative 1/3 times 3 to the, and then our 3 is going to be, I'll put everything in parentheses just to keep it safe, 3 to the -2 power. And we get, if we want it as a fraction, -1/27. And I'm going to keep it as a decimal, -0.04. I'll just round to -0.04. And if you want to write down what you did in your calculator, it was -1/3 times 3 to the -2nd power. And then you're going to keep plugging those numbers in. So you'll do the same equation, but now we're going to do it to the -1 power. And we get -0.11. And you can show what you plugged in. We did -1/3 times 3 to the -1 power. And then that's just going to continue. So we'll plug in 0 now. We end up getting -0.33. +1 will be -1. Let's see, I'm going to kind of draw a line. This is getting a little confusing. There we go. And 2, when you plug in 2, you end up getting -3. Okay, let's plot those points. So -2 and -0.04 is going to go left and down just a tiny itty bitty bit. And the -1 is going to go left and down again just a tiny little bit. And then 0 and -0.3 is down just a little bit more, still very tiny. And 1, -1, right and down. And then 2, -3, right and down. So you can see the exponential function is starting to come together. We have that J-looking function, and it's going to start decreasing very quickly there, and this will approach the x-axis.
All right, can someone please help me? She's making a video.
If anyone just heard Miss Snavely, Miss Snavely, say hi to the kids.
Hi.
Okay. All right, so we're going to do another one with negative 0.5 in the front. She's still here. Bye, Miss Snavely.
Hi.
Everybody say hi to Sammy. Say hi, Sammy.
Hi.
Okay. So there's nothing being added or subtracted to these x's up here, so we're going to use -2, -1, 0, 1, and 2. So when we plug -2 in, we're going to do -0.5 times 5 to the -2, -0.5 times 5 to the -1, -0.5 times 5 to the 0, -0.5, hold on, there you go, times 5 to the first, and -0.5 times 5 squared. You're going to plunk those in your handy dandy. I just called it a handy dandy. And we get -0.02. And I know everyone is using their own calculator at home, so they know exactly what they're doing when they come in tomorrow. You can use a phone calculator. They're not the best, but if you work your butt, if you have a Droid, the calculator on there is a lot more user-friendly, but it'll all work. Whatever you pick. And the last one. If you are wondering how I can so quickly type that in my calculator, I'm just hitting second and enter, and that brings up the last thing I typed. Okay, so when we plug that in, we plot our points. We have -2, and I get super, super, super tiny, and -1, and something very tiny again. The screen is like going super bright and then super dark. And then 0 and -0.5, so that one's a little easier, right smack dab in the middle. 1, -2.5, at least they're getting easier to graph, and 2, and 12.5. We're a mess over here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12.5 will be here-ish. Do you like that? Graph them, and you're good to go. And there's your J. Whee! All done. If I asked you how that compared to the parent function, the parent function would just be y equals 5 to the x up there. So it would compare by saying the negative would reflect it. I can spell reflect. And that's smaller than 1 that you're multiplying by, so that would be a vertical compression of 0.5. That was fun. On to the next one. Sammy just told me that you guys don't pay attention to my videos, and I choose to believe that's not true. Okay, so here on they're going to like these ones. We're on problem 2. Problem 2, we're going to move this graph left and right, and the reason it's going to move left and right is because now something is up here in the exponent with x. But don't worry, it's the same it was in Chapter 2, Chapter 3, Chapter 4, and Chapter 6, because we didn't do Chapter 5 yet. Long story short is when you have a -4 up here, you're going to keep your typical x values as like a reference point. So those are your typical x values, -2, -1, 0, 1, and 2, just like they were up there. But we're going to do the opposite of what we see in the parentheses, just like we did last chapter. So if you see a -4, you are going to add 4 to all of these values for your new XY chart. So I was so sweet, I even have that down here. So here are your usual x's, -2, -1, 0, 1, and 2. But because there was a -4 in the parentheses, we need to accommodate for that -4 by doing the opposite, by adding 4. So -2 plus 4 is 2, -1 plus 4 is 3, 0 plus 4 is 4, 1 plus 4 is 5, 2 plus 4 is 6, and that's why I picked those new x values. And that gives us a nice picture of what the graph looks like. So that's, I have a reason, I promise, I'm not crazy. All right, so when we plug it in now, we're going to plug it in the same way we have been. We have 2 to the power, and your calculators are nicer. I don't think you even need parentheses, but I do. So instead of x minus 4 like that, we just change this x to whatever x value we're plugging in. So 2. Hit enter, answer is 0.25. Do it again, plug in 3. 0.5. Do it again, plug in 4. Do it again, plug in 5. Do it again, plug in 6. And now you have your beautiful new points. All you need to do is plot them. So you'll plot 2 and 0.25, so very short. Plot 3 and 0.5, right in the middle. 4 and 1. 5 and 2. And then 6 and 4. 1, 2, 3, 4. Wait, 1, 2, 3, 4. There you go. And you see this nice J shape coming into view. Since we did not move it up and down, we only moved it left and right, it will still approach the x-axis. So we'll just kind of indicate that with an arrowhead approaching the x-axis. I don't know why this keeps getting brighter and darker. It's driving me crazy. Let's try that. Oh, look, another fun-filled problem. This is exciting. We are just going to make a table for the translated one, which we've been doing. You don't know, I've redid the notes because I used to be really mean and make you do a whole bunch of extra stuff. This one is not moving left or right, so it is not being moved left or right. Oh, I should put that on the last one. Everybody flip over. This last one, do you remember that this -4 with the x, that it moves it to the right 4 units? There you go. Probably should have put that on there. My bad. Next. Okay, so this one doesn't have anything with the x's, but this 10 in the back is going to move it up 10 units. So when we move it up 10 units, that's not moving it left and right, so we're going to keep our x's what they were originally. So you only change your x's if you're moving left and right. Why don't you write that down at the top of the paper? Then I'll know you actually did your notes. I'm not going to write it down, so I know you're listening. At the top of your notes, put, you only change your x's if you move left and right. Good for you. So we'll do 20 times 1/2 to the -2 power and then a big plus 10. And you're just going to be doing the exact same thing you were doing. To the 1/2 to the -2 power and then a plus 10 gives me 90. That's a big answer. Wow, that's obnoxious. It's kind of my fault for making the graph. Okay, now plug in -1. There's another big answer. Now plug in 0, 30. Now plug in 1. 20. Now plug in 2, 15. Plot those points if you want to. I don't want to, but I will. So we're going to skip by 10s on the y-axis so we can actually fit it in. -2, 90. 10, 20, 30, 40, 50, 60, 70, 80, 90. See, we can do this. -1, 50. 10, 20, 30, 40, 50. 0, 30. And 120. Oh, that wasn't so bad. I made a really big deal out of nothing. And then 215. Okay, so remember we were counting by 10s. So when we graph this, you're going to see now that it does have that, there's that J formation, but it is not going to approach the x-axis anymore. It is now going to approach the 10 axis, so like where y is 10. So it's never going to go below 10 anymore because of the 10 in the back. On part 2, it says, how does the graph of each function compare to the parent function? So what we're going to do here is, because the +2 is with the x, I'm going to write +2 with the x. That moves it to the left 2 units, and that's all it does. Part B has a lot of stuff going on. So if it is asking us about like how it's translated and stuff, this would be like the parent function, just that part right there. And then that 5 in the back, that would move it up 5, so it would like approach y = 5. And then this 5 in the front would be a vertical stretch of 5. So it says, how does the graph compare? So this one, if that's the parent function, it would be a vertical stretch of 5, and it would be up 5. We are going to, on this one, since your x's would change, like this one you would use on your xy chart, you would still use like the typical x values because it's not moving left and right. But on this one, because it is moving left and right, you would have to change them. So since there's a +2 up here in the parentheses, you would have to take your typical x values, these are the typical ones, and you'd have to do the opposite. You'd have to do minus 2, minus 2, minus 2, minus 2, minus 2. So your new x's would be -4, -3, -2, -1, and 0. All right? So if it's moving left and right, always make sure that you change those x values.